In this video, we are going to talk about the special case where I can calculate the definite integral just using areas. Just using my knowledge of geometry and areas, I can calculate the definite integral. So we're talking about the case when we do not need to use the limit of the Riemann sums, okay? And this is, like I said, it's a special case. So here's my first example. I'm given this graph, and that's all I'm given is just a graph, and I'm asked to calculate these definite integrals. So all I really have here is I don't have any formulas. I'm going to have to use the area. So let's start working on this. So for part A, I'm asked to find the area, the definite integral from 2 to 5. So that is right here. So I'm going to be looking for this net area. And to me, it looks like a rectangular shape. Okay, and the base of the rectangle has length 3. And the height of the rectangle is 1. So I would say this is a rectangle. And so the area is base times height. But since it lies below the x-axis, I'm just going to add a negative there. 5 minus 2 times the height is 1 of the rectangle. So this is going to be negative 3. So the answer to the first part is negative 3. So let's do part B. In part B, we're asked to find calculate the definite integral. So from x equal 0 to x equal 2. So we're looking at this area right here, right there. We would like to know what that area is. Okay, and in this case, I would say that looks like that is a triangle, right? So in this case, but it lies below the x-axis, so again, I'm going to have a negative there. And what is the length of the base of this triangle? Well, it's 2. And what is the height of the triangle? It's 1. So the net area there is negative 1. So let's work on part C, and it is the definite integral from negative 2 to 0 of f of x dx. So negative 2 to 0 is over here, and if you look at the graph, it's there. So the area that we are interested in, it lies above the x-axis, and it is half of a circle, and the circle has radius 1. So I am going to be able to calculate this as pi r squared over 2. Where r is equal to 1. So this is just pi over 2. Okay, and then the final integral we were asked to calculate is from negative 2 to 5, the definite integral. So that's all the way from over here to 5. So that's this area as well as the circle. So if I had to shade that area, it would be this area. Okay, how do I calculate that area? Well, fortunately, I can just use my work from the A, B, and C. And integrals have this nice property that the integral from negative 2 to 5 is equal to, so let me do this over here. This integral is the same as the integral from 5 to 2 plus the integral from 2 to 0. Plus the integral from 0 to negative 2. Okay, so I can break the integral up like that, which is really nice. So that's negative 3 plus negative 1 plus pi over 2. So my final answer is pi over 2 minus 4, and that is my net area. So here's another example where I can use the area, and the fact that the definite integral is the net area. So in this case, f of x is just equal to 3. So you might usually see that written as the horizontal line from y equal 3. So let me just draw my graph. So here's my line. And I am evaluating that from, let's see, I actually need to go a little further here. 1, 2, 3, 4, 5, 6, 7, maybe 8 is about here. Here's -1. So I'm interested in the area between the line y equal 3 from -1 to 8. So above the x-axis and below my horizontal line, y equal 3. I'm interested in this area, and you can see that's just a rectangle. So we're going to do base times height. It lies above the x-axis. So the base has length 8 minus -1, and the height is 3. So this gives me 9, 8 plus 1, so 9 times 3, which is 27. So here's another nice example for which we can use area to calculate the definite integral, so we don't need that limit definition. So first, let's take a look at our function. Y equal f of x is, so this is like the absolute value function, but it has been reflected across the x-axis. So let me just draw what that looks like. Okay, so the graph is going to look looks like this. Okay, and the area that I'm interested in, so we're looking at the interval from -2 to 4. So it's like this triangle plus this smaller triangle. So this is the net area that we're interested in. It's the sum of two triangles. So all we have to do is we just have to figure out the area of the smaller triangle here. Okay, so let me actually break that into two integrals. So from -2 to 0, because that's the first triangle, plus -0 to 4. It's the second triangle. So that would be a negative, because it's below the x-axis, base times height for the small triangle, plus -1/2 base times height for the large triangle. So for the small triangle, we have -1/2 2 times 2, plus we have -1/2 4 times 4 for the large triangle. So this is -2 minus or plus -8. So our area is -10. So let's do one last example. So at first, this example might look a little bit complicated. We have the definite integral from -9 to 0. So these are our bounds of integration of the function 3 plus 2x plus the square root of 81 minus x squared. So I'm going to use the properties of definite integrals to break this big problem into smaller, easier problems. So this integral can be rewritten across the sums. So I have from -9 to 0, the integral of 3 dx plus the integral of 2x. And I can actually pull the 2 out, so I'm going to do that. And then when it's written like this, it makes life a lot easier because I can see that, oh, this is just going to be a rectangular area. This is going to be some sort of a triangle, and this is a circle. So the nice thing about this is that we have, once we break them apart, we can see part of a circle, we can see triangle, and we can see rectangle. So these are all those special easy cases where we can actually easily calculate that area. So in this case, if I'm looking at the interval from 0 to -9, so this is 1, 2, 3, 4, 5, 6, 7, 8, 9, -9. You can see that this is just going to be a rectangle with, let's see, base 9 and height 3. This is going to be a triangle that lies below the x-axis. So it's going to be a triangle like this that has base 9 and height 9. So we're gonna make it negative though. And then this is our circle. Okay, so this is a circle, the top of a circle with radius 9. Yeah. This is going to give me a quarter of a circle, right? So that is actually going to be plus pi times 9 squared over 4. Okay, so we have 27 minus 81 plus 81 pi over 4. This gives me 81 pi over 4 minus 54, and that would be my final answer.